Hello, flatties and ballers. Critical thing from down under, and I'm back again for part 2 of my 100% curvature video. Let's get on with it.
Okay, we have a boat here that's not over the curve. We have a ship here that is over the curve. We have a ship here which is not over the curve. And we have the same ship which is now over the curve. So this one's now gone, we've gone lower and the ship's actually heading away from us. And now all that middle section of the hull is obscured by the curve now. So what I'm going to do, what I did with I took the camera up higher again, and I've just left the camera on while I've done that, and that's why this all looks quite a bit funny. Stepping, step, step, step. Next time I'll try and do this better. So I'm going up a little bit, and just to see what's changed. And when we find the ship again, there, look, you see the middle part of the hull again. Magic, it's just appeared. Because our height is higher, we can see further over the curve. Really simple. Let me go here and find our other ship. Oh, we found another ship. Didn't see that one before. And here's the ship's now appearing higher above the curve than before. And we'll go down the steps again in a minute. There's that third ship. Focus not so good, but you can tell what's happening there. Then we're going down the steps again. Set up the camera on the sand. So I just left this running just so that you can tell that this is just one after the other, and now you can't see the hull again, which is exactly as you would expect from observations over a curved surface. And there you can't see the red part of that. Remember, that had a red underneath before. You cannot see that now. The water level's right up to the writing on the side of the ship. And we should pan. I should be panning right. And yes. Yes. And again, see less of that ship. That one's anchored, not moving. Okay. Now we'll go a little bit more. There. So, this ship continues to move away from us, getting lower and lower over the horizon. And it looks like this one might be over the horizon too, but I'm not gonna say much about that one. That's not the focus. So here, there's something I do want to point out in this photo, because some flatties claim that the bottom of the ship has disappeared because of atmospheric compression. Right, I've seen them complain about, like, you know how when you can see the top 100 feet of a mountain and, oh no, you shouldn't be able to see it, but the bottom 2,000 feet is actually missing. But that's because of atmospheric compression. Compresses 2,000 feet to nothing, apparently, which is, of course, complete bollocks. And here you cannot claim atmospheric compression in this case, because you see this little square here on the front of the ship here. It's actually not, it's actually not compressed. Now it may, and the mirroring is very hard to make out, so it's more an elongation than anything as far as I can tell. But in the other photos, this was a very small part here, and rather than a mirror here, it looks to be elongated. So there's no compression here. It's actually a slight elongation because of atmospheric effects very close to the surface of the water. And I gotta work out how to get my arrow back. More pictures. This particular shot of the one in the middle, the Indra, there is a small amount of reflective. Now look how small that is. Now, flatties try to use this amount of reflection, some kind of evidence that it's not over the curve. Well, this here is so small, it's not gonna hide the whole hull. And then I've even seen one flatty say, well, just because there's a mirror there must be another mirror under it, which is complete bollocks, of course. But I don't care if you put another mirror under that one in this case, because that's only going to go take it down to about there, and we've seen that the hull's much bigger than that. So I don't know how you're going to hide. What's your excuse, flatties? That ship is definitely sunk down. Look at that. And look at that. Same distance ship. You're not going to be able to claim density of the air. That's just curvature. Changing observer height changes the amount of curvature hidden. It's really simple. There it's demonstrated. And there's the amount of ship that was hidden before. And again, you can see it's very hard. It doesn't appear to be any mirroring at all. If there is, it's very little. So it was a good day for observations. And this ship, there's a slight amount of mirror on the bottom here in this part. But when the water rises up, that swells up, that disappears. And there's that window which is longer before. Ship disappearing. Bye bye ship. Gone over the curve. Bye bye. So I've also taken some photos of the island just to compare, because it's not far enough away, this island, to be over the curve. So we're going to compare what it might look like on a flat surface. So if those ships were on a flat surface, then you can see, looking down, You can see the bottom of the island. You can see the horizon beyond that, and that's the left end of the island. And as we get lower, you can see it's lower because the horizon's dropped there. You can still see down to the bottom of the island. As we get even lower, you can still see the bottom of the island and bottom of the island. Now, if there was flat right out, those ships, you would be able to see the bottom of them. You can't. And so now I'm going to go ahead with debunking the debunkers to do with this. And there's a bit of smack talk there about Wolfie, about Mr. Perspective claiming that the video that Wolfie put up may be fraudulent by the looks of that. And then one other explanation would be the smaller angular size of the distant boat is being obscured by a closer respective angular size of the waves. Yes. I don't see how that's possible. You can fake curvature by bringing the camera lower to the surface so that the waves have more of an impact on obscuring distant objects. So how close was my camera to the water? The wave's not even, look, even when I was right down, the camera height there is still higher than the waves. And with my ships, I'm always much higher than the waves, and the waves are very small compared to a ship. Now, don't forget the waves are getting further away as well. So you can't say, unless I had my camera in the water, you can't say that the waves will obscure the ship. That is, I just have to say that's ridiculous. And so that's why so many globe shill videos are shot when the waters are rough. Okay, mine wasn't shot when the waters are rough. Bam, debunked. They're using the waves to fake curvature. No, sorry, you just cannot say that here. The waves are insignificant in my videos and my pictures. Sometimes it's both atmospheric mirroring of the water and an angular size issue. No, there's no, very little, in some photos there's no atmospheric mirroring, and there's very little atmospheric mirroring on this particular day. And that's what happens. The conditions change. Sometimes you get mirroring, sometimes you get refraction, sometimes mirages that cause the ships or boats to appear higher than what they really are. And these are the ones that Taboo Conspiracy cherry picks and says, look, the Earth's flat. And at the same time ignoring everything like what I have presented here today. And that's why he says Wide Awake has so many videos proving that the Wolfie video is at least, very least, a disingenuous claim of curvature. And Wolfie knows that. No, I'm afraid that's, I just don't agree with that. What Wolfie is showing is genuine. What I'm showing is genuine, and what you have shown with some of your videos, I understand that they represent a refractive, but I know it's no good me saying that. But I'll illustrate why another day. And Mr. Taboo Conspiracy is going to make a series of videos on how to fake curvature with 3 techniques. Go out when the waves are high and bring the camera lower to use a larger respective angular size of the closer waves. Okay, you can do that if you want, but it's going to look nothing like what I've shown here today. I have not brought my camera down to where the waves are. The waves are not obscuring the ship. They're like, yes, I can make a wave obscure a ship if I bring the wave right up next to my face. But that's not what's happening. and they use the mirroring line as a curvature line. That's not happening. I had very little or none mirroring line. Use atmospheric compression to fake a new horizontal line. No atmospheric compression, I've shown that. So, all bollocks. So here's why, this is my little diagram about why, how waves cannot obscure a ship. Now a ship is something like 90 feet high. This is not really to scale. These waves here I've drawn, I don't know, they're actually somewhere between 1 and 2 meters, maybe more. So the only way the observer is going to have the waves obscure the ship, see, it's going to block his line of sight, is if he is below the top of the waves. And you know, that's pretty low, very, very low. You're going to have your nose in the sand for that one. And you can clearly see in my pictures and videos, I am well above the waves. So I really don't know how that works. That's absolutely crazy. And then we have Mr. Phuket Word's interesting little Lego block. So if you want to put the Lego block in front of your face, it can obscure a ship. Well, that's relevant, isn't it? You can tell here that this Lego block obscures something bigger than it in the distance. Well, of course, the Lego block is in front of your face. And the inference here is this ocean is like a Lego block, and of course the ocean is and the waves on the ocean, you can see how much bigger than the ship they are. Well, they're not. Look, there's a wave there. You can see that there's a wave there, and the Lego block waves are not even close to your face. So I don't know how anyone in their right sane mind can think that a Lego block in front of your face is the same as looking over the ocean. I think we'll leave it at this picture, which clearly I don't know what happened to the Lego block. It got lost out there in the ocean somewhere. But the Lego block has become very small way out there. So no doubt the flatties will say, that's not curvature, that's perspective, or some such lame thing, I don't know. 101 reasons, but it's clearly curvature. Thank you very much for listening and watching. And yeah, if you like my videos, please subscribe. And I'll be back with another video another time.